Hi there. You are looking at a piece of digital crud, as I like to put it, that appeared on 3.710 kilohertz yesterday afternoon. I'll switch my Bose off, but now that you've heard it. Yeah, it appeared on frequency yesterday afternoon during the sked, Wednesday afternoon sked that starts at 1400 hours UK local time. And it was towards the end of the sked it appeared, don't know, maybe 10 to 3. And obviously, as a shortwave DXer of many years, I recognised it as digital noise. I've seen this, well, thousands of times probably over the past few years, heard it, because these types of signals appear across the HF bands. And I'll show you some examples in a minute. But obviously, rather annoying that one has decided to, has appeared on our 80 metre band sked frequency. So on a Wednesday afternoon, the sked is entirely on 80 meters on 3.710 plus or minus QRM, and on the Friday night sked we start on top band 1.846 megahertz and QSY to 80 meters 3.710, and it looks like we're not going to be able to do that excuse me, because this signal has now appeared, and no idea how long it's going to remain. You can see that it transmits for about 5 seconds and then switches off for a second or so in a very sort of regular fashion. It looks a bit like a broadcast DRM signal, but it's only 3.4 kilohertz wide, so the bandwidth is nowhere near wide enough. I think DRM is like 10 kilohertz, and I've tried to I've tried the DRM filter on this signal, and it doesn't lock. There's no information. So if it is a DRM signal at all, it's not a broadcast signal, but for obvious reasons it's switching on and off anyway. But what is interesting is that if you go down to the medium wave band, if you go down to the X band, so that's the band between 1.6 and 1.7 megahertz, and it's referred to as the X band because it's the medium wave band extended, and
80%.
This is a part of the band where over the years I've copied many DX signals. For example, on 1660 kilohertz you can quite often hear Puerto Rico at night quite strongly, and numerous copied Dallas on medium wave, many North American stations. But if I go to 1.68, there is another identical, well, it's not, this isn't an identical signal because this one, I'm not sure if this one even switches off at all, but it's the same type of signal. It's a digital signal that on the face of it looks like DRM or broadcast DRM, but the bandwidth is too low. This kind of sweeping kind of motion where that's very typical of a broadcast DRM signal. But so there you go, and you can see the patterns now developing on the waterfall. So that's basically inside, not exactly the medium wave band, but in the medium wave band, in the X band, so the top of the medium wave. I'm not sure if I've ever seen one within the medium wave band itself, but anyway, so that's 1.68 megahertz, and if we just sort of click up 1.9, there you go, 1.9 megahertz, 2 megahertz. You know, as I said, these things they're everywhere. 2.1, 2.2 megahertz, 2.6. There you go. So 2.58 to 2.62, 2.8 megahertz. Again, 2 more. There's just examples everywhere. 3 megahertz. Now there's a signal called Radio Mozov-Chasky on 3310, which is often affected by this type of digital signal. So here you go, 3.29. You know, as far out, 120 meter band, 90 meter band, 60 meter band, these signals are there. 3.1, 3.2, 3.3. So that one's on 3320 kilohertz. That one's sweeping on and off. There you go, there's another one. 3.34, 3.35, 3.36, 3.37. They're literally everywhere. And what's interesting is if I go to 4055, that's Radio Verdacci, the broadcast signal, commercial radio station, tropical band radio station. And what's interesting is there used to be one of these digital signals right here, and that one disappeared. But there are so many. They're literally everywhere. And I don't actually know what they're for. There's been sort of some speculation there might be some kind of radar, but I would expect them to be sweeping and not sort of constant. So if we go down to 3.71. Yeah, so there you go. It's a little bit annoying, to say the least, and it'll be interesting. Oh, here you go. So here's a DRM signal. I think so. That is definitely DRM. So let's go back to the DRM mode and go to info and put the audio back on.
Battery 80%.
There you go.
à Yaoundé et à Kinshasa. Vous écoutez. Et c'est le journal de Sylvie Berruet. Bonsoir Sylvie.
Bonsoir Bruno Fort, bonsoir à tous. En République démocratique du Congo, au lendemain de la motion de censure qui a fait chuter son gouvernement, le Premier ministre Sylvestre.
This is, I think this is Radio France International. And if you look at the filter bandwidth here for DRM is 11 kilohertz. And you can see, I'll just turn the volume down a little bit. You can see the sort of steep sides, a bit like a sharp filter, and then this kind of wave of across the top of the signal as the data is transferred. Two things about DRM. The idea of DRM, Digital Radio Mondial, is that it reduces fading, the effects of fading for shortwave broadcasts on HF. And I think that's true, but the problem is that the audio is very tinny and probably not a very nice listen after half an hour. You can see if you can. It's very kind of artificial kind of audio, sort of processed in some ways, but you get the idea. Anyway, there you go. So that's what a DRM signal actually looks like. So much broader signal, steep sides, and yeah, not really very similar. Similar only in terms of, I suppose, the fact that you've got a signal that clearly it isn't obviously AM, any other type of modulation. It's clearly not FM or AM, although interesting that Radio China signal with such steep sides did look a little bit like a DRM signal, but that's an actual signal from France. So there you go. Compare that. If I just very quickly go back to 3.710 without changing the scale, you can see the difference. So that's Radio France International, and that's our noise. So from 11 kilohertz back down to about 3.4. About 3.4. So there you go. Anyway, I hope that was useful. For perhaps more so for members of the club than anyone else, but I just thought I'd share that, and I'll share a link to the club members as well. So interesting to see these signals, and but it'll be very nice if this signal disappears. Anyway, thanks for watching. It's 7-3.